Hello everybody, welcome to section 6, which is IPv4 class A subnetting. As we have done a lot many calculations already, so let me go through this subnetting very quickly in the tabular form and explain you, and you will have to practice them by yourself. Okay, this is the tabular form of class A. So this is the default subnet mask and corresponding default prefix length. So when we borrow 1 bit, it becomes /9, borrowing 2 bits becomes /10, and so on and so forth. And this is the number of networks we get, and these are the number of hosts we get. So as number of networks increases, the number of hosts per subnet decreases. So these are just the 8 bits. Let us go to, these are the 8 borrowed bits, okay, not the first 8 bits. So this is the default. Then we go to the, so this is the second octet. Now let us go to the third octet. So here is the third octet. From here we are into the fourth octet. So we see that as the number of borrowed bits increases, the number of subnets also increases, and correspondingly the number of hosts per subnet decreases. And finally, when we borrow 22 bits, we have got only 2 hosts, but we have got so many subnets. So this is divided into 3 videos. So in this video we'll see 7-bit, 8-bit and 9 bits. Then in another video we'll see 15, 16, 17, and finally we will see a single video where we borrow 22 bits. So this is /30 for class A. So there will be /30 for class B also, and we have also seen /30 for class C. So this is exactly same like class B and class C, but the only difference is this will have a lot many number of networks. In fact, we have seen more than 4 million subnets. In either case, there will be only 2 hosts. For class B, this will be /30, and there will be 8 bits less. So 2 power 8 is 256. So if this number is divided by 256, that many subnets will be there. Okay, let us see. Let us come to the first video of this class A subnetting. Borrowing 7 bits means /15. Borrowing 8 bits means /16, which is same as class B default subnet. And borrowing 9 bits means /17. Let us see the example of borrowing 1 bit. So if we borrow 1 bit, there will be 2 networks, this many hosts per subnet. The magic number we get from this value. 1 bit has been borrowed, so 1 and then remaining zeros, so 128. So we get the block size is 256 minus magic number 128. So this gives the next subnet, and this is in second octet. So the new subnet mask will be, so this MN, put it over here, so 255.128.0.0. So there are 2 networks. Second network -1 will give you the first network's broadcast address. 1 added to the network address will give you the first valid host. 1 subtracted from the broadcast address will give you the last valid host. Same thing over here. So if you count from here to here, this will be 8,388,606 after subtracting 2, because this is the network address, this is the broadcast address. We cannot assign network address and broadcast address to the host. So this is short description when we borrow 1 bit. Let us see what happens when we borrow 7 bits. So we have 128 networks. We have got 131,070 hosts per subnet. This is the magic number. See, 11111110. So this is 254. So magic number higher means block size lower. Block size lower means more number of subnets we have to deal with. Now put this one over here and you get the new subnet mask. So block size is 2. So there is an incremental value of 2 in the second octet. So second octet incremental value by 2. So 0, 2, 4, 6, 8 all the way to 252, 254. So these are 256 subnets. 256, sorry, these are 128 subnets because this is 2. So total is 256 and incremental value is 2. So 256 divided by 2 is 128. So these are 128 subnets. Same formula, second subnet minus 1 will give you first subnet's broadcast address. 1 added to the network address will give you the first valid host. 1 subtracted from the broadcast address will give you the last valid host. Do the same calculation and you should be able to get through. Let us see what happens when we borrow 8 bits. So 8 bits are already there. If we borrow 8 more bits, it becomes 16. So this is similar to class B's default subnet. The only difference is in class B default subnet there is only one network, whereas over here there will be 256 networks. Use the same formula to calculate the remaining values. In this case the block size will be 1. And this is in which octet? Second octet. So what happens in second octet? There is an incremental value by 1. So 0, 10.0, 10.1, 10.2, 10.3 all the way to 10.255. So these are the 256 networks. Subtract 1 from the second network and you get the first broadcast. Subtract 1 from the third network, you get the second broadcast. Use the same formula by adding 1 to this network and subtracting 1 from this broadcast address. So these are the 256 subnets. Let us see next one. When we borrow 9 bits, the number of networks doubles. Earlier it was 256, so now it will be twice. We find the number of hosts, get the magic number. Now this is in the third octet, remember. The second octet game is over. So when we borrow 8 bits, we are still playing in the second octet. But when we borrow 8 bits, our game is in third octet. So magic number is in the third octet. Find the block size, which is 128. So this will be in the 128 is the block size, the incremental value in the third octet. And then we get the new subnet mask. So this magic number goes over here in the third octet because we are playing in the third octet now. So third octet 0.0. Now third octet incremental value is this block size. So 120.0. Now after this it will become 10.1.0.0, then 10.1.120.0. So 0 series has got 2 subnets, 1 series has got 2 subnets, likewise 2 series will have 2 subnets, 3 series will have 2 subnets. When I say 0 series, it means the second octet is 0. When I say 1 series, the second octet is 1. When I say 2 series, the second octet is 2. So like this we will come up to 255. So everywhere we will find 0.0, 120.0. So two of the subnets all the way, 2 of this. So totally we will have 512. That's it for this particular video, because we have seen borrowing 1 bit, 7 bits, 8 bits and 9 bits. So see you in the next section where we will borrow 15, 16 and 17 bits. Thank you. Thank you for watching this video. See you in the next video. Bye. Bye for now.